As many of us may know, Harvard was founded in 1636, almost 400 years ago. The lives were completely different. Horses and carriages roamed the street, tired students were guided by candlelight, and the newest fashion trend, buckled shoes, were here to stay. As much staying power as it might have, the lives of college students have changed dramatically at Harvard. But no matter how long Harvard stays in Cambridge, forever chemicals, PFAS, are here to stay.
Do you know what PFAS are?
No.
No, some kind of chemical. PFAS just sounds evil.
If you're like these students and have no idea what PFAS are, then you're in the right place. PFAS have been a hot topic in recent years due to how widespread they are and the harmful effects that they're linked to. But what actually are these chemicals? Welcome to our complete guide on PFAS. PFAS are a group of manufactured chemicals that first came into our lives in the 1940s during World War II. They have many different uses, including a non-stick agent for pots and pans, stain and water resistant for furniture and clothing, and to make firefighting foam more effective. And due to all the many different uses they have, they grew in popularity quickly in America and across the world. And because of this, they still infect many of the items that we come into contact with today. PFAS stands for per and polyfluoroalkyl substances. If the name sounds complicated, don't worry. Industrial companies purposely made it that way to confuse people. So let's break it down.
Per in chemistry means fully. Poly means, in this case, partially. What are fully and partially referring to? PFAS consist of fluorinated carbon chains. Each of those carbon atoms have some number of atoms of fluorine connected to them. This is where we get the fluoro, and thus a fluorinated carbon chain is formed. The alkyl substance at the end simply means there is a carbon in the molecule. At the end of each chain of fluorine carbon atoms is a different head group. Head groups are the part of the molecule that attach to the fluorine carbon chain. These can vary slightly in structure, but create thousands of varieties of PFAS. Some of the most famous that you may sound familiar with include PFOA or PFOS, also known as PFAS. While carbon bonds can normally be broken down and decomposed, such as when a living thing dies, the fluorine-carbon bond hardly ever breaks down. And if they ever do break down, it is usually into smaller PFAS, but this never occurs in nature. The only part to completely break down is the head, which leaves behind the carbon-fluorine chain. This property has earned PFAS the title of forever chemical. PFAS have many routes of contamination that result in accumulating in us. Eating and drinking contaminated food and water are the main areas of contamination in humans. Through these many routes, PFAS are estimated to be in the blood of more than 98% of humans.
The most common source of PFAS contamination in the United States is actually in firefighting foam. And this is most commonly used in airports and in military bases, but not just when an actual fire occurs, also in their routine training. Thankfully, there have been recent bans on PFAS in firefighting foam, but their previous use still needs to be addressed.
PFAS and firefighting foams leak into the ground. They eventually move into groundwater and surface water found in rivers, lakes, and oceans. Once in water, PFAS build up or bioaccumulate in fish and other animals, which are often consumed by humans.
Recently, there are now fluorine-free foams that are available, and there's a big push by government to transition to using these fluorine-free foams.
So this map shows confirmed places of PFAS exposure and also suspected exposure from drinking water due to airports and military bases being in close proximity. But while this is scary to look at, the good news is that the EPA is at the first enforceable PFAS maximum contaminant level. And we learned from this that over 80 million Americans are above this limit. And that's only talking about 2 types of PFAS.
It's important to look out for these chemicals to protect your own health, as research has linked PFAS to many conditions and adverse health effects. However, it is important to note that research has only mainly focused on 2 types of PFAS, which means there are likely many more threats that we don't even know about.
Well, if they're everywhere, is there anything we can do to protect ourselves?
The first is awareness, making people aware that PFAS exist and that they're exposed to PFAS, because then that pushes them to think about their consumerism and the products that they're using and buying. One thing is to switch the types of products that you're purchasing.
Well, what can Harvard do to protect us?
Can we make our buildings safer?
Trying to avoid furniture with stain-resistant properties is always a good rule of thumb for avoiding PFAS. Some distributors and manufacturers are already avoiding creating and selling furniture that contain PFAS. And you can always find a good list of PFAS-free distributors, such as the Green Science Policy Institute.
I think one of the most important things to know about PFAS is that These chemicals are everywhere. They are persistent. They are used in many of our products, and you should be aware that they exist and that we don't really have a great understanding about exposure to most of these chemicals, even though they've been around for decades. And it's important to push for better chemical regulations moving forward so that we don't continue to have these types of problems in the future.
While PFAS are here in so many products in our daily lives, there are a lot of steps we can take to minimize our exposure going forward. One step you can take is learning about the harm of PFAS and where PFAS come from, and you've already done that. So moving forward, try to get rid of at least one product that contains PFAS. I promise it'll make a huge impact in your life going forward.